I'm Akshika Sundara. I'm a second-year PhD student here at Open University. I research in smart homes and more specifically about adaptive user interfaces which can preserve privacy of smart home users. I'm more driven towards this research topic because of my interest towards technology. I've been growing up with technology as a kid, playing with computers, playing computer games, and now it's driven towards working in smart homes. And now there's huge research gap with regard to privacy. You might have seen on news with that privacy violations happening on social media. Now it's happening within smart homes due to Alexas and those kind of devices. So I try to fix this problem, giving a solution to preserve privacy within smart homes. So in the future, the solution that I'm giving is a software system and a set of algorithms that could actually drive, be a guideline for engineers who build these smart homes, which would actually keep the privacy in the core of design, so that whenever you build smart spaces, not just smart homes, be it any kind of smart space, would actually preserve privacy of smart home users, and so it would be good for the smart home users. Hello everyone, good morning, and it's a sunny day, so it's great. So my name is Akshika. I'm a second year PhD student here at OU. So you can find me on my Twitter handle, you can go to my website. So let's go to my topic. So today's talk is going to be about how we can model privacy preferences and user interfaces in smart homes. So my supervisors are Arosha Bandara, Blaine Price, and Bashano Sebe. So let's look at a scenario. So a smart home. So what is a smart home? So a smart home, in general definition, is a home which has actuators and sensors and user interfaces which are connected together to help you to do your daily activities. So that's the basic definition of a smart home. So because of these ubiquitous user interfaces and sensing, there's a risk of your privacy being violated. So it's important that we set out the smart home is able to preserve your privacy whenever you live and do your daily activities in the smart home. So this is the first scenario. So there are three people. Let's focus on two people at the beginning. So there's a care receiver and a caregiver. So a care receiver has a privacy preference that he or she does not like to share. He or she will only share their health data with the caregiver. He will not share that information with anyone else. So in a scenario where this information is broadcasted to a smart speaker, something like a public user interface, if someone else comes into the room, the smart home, there's a risk of someone else overhearing this information and this information being leaked, which leads to a privacy breach. So this is the first scenario. The second scenario is that so the care receiver has a preference not to get disturbed while he or she is meditating. So this is the other spectrum of the privacy where it's about right to be let alone, that you need to be in peace. So there are smartphones and smart speakers everywhere in a smart home, and there's a risk of your privacy being violated because someone else could call you, some notification could go up. So there's this risk of privacy being breached. So these are the two types of privacy I'll be talking about. So I'll talk more in detail in the next slide. So you can categorize privacy in many ways. So one of the ways I've tried to categorize is in this way, where the main two ways you can categorize is privacy violation with regard to information disclosure, the second being disturbances that could happen to the user. So the information disclosure can be happening in two ways, which is outside the smart home, where the information is leaked to third-party companies and third-party stakeholders. But I'm not looking at that side. I'll be focusing on privacy violation which happens inside the smart home within smart home users. With regard to disturbances, there are two ways normal disturbances could happen to smart home users. The first being which happens because of the user interfaces, and the other being other factors. So I'll be focusing on disturbances which are caused due to user interfaces. So these two are the two main privacy aspects I'll be focusing in my research. So when it comes to user interfaces in smart homes, just like privacy, there are many ways you can categorize these the user interfaces. And one is actually as privacy user interfaces and other being public user interfaces. So public user interfaces are user interfaces which actually can transmit broadcast information to multiple people. So you can take like smart speakers, go under audio user interfaces, graphical user interfaces like smart TVs, ambient lights, smell-based user interfaces. So there are so many examples under public user interfaces. So I'll be focusing on that aspect of user interfaces in my research. So this is my research question. So I'll be looking at how smart home user interfaces can be adapted in a way that helps to preserve privacy of smart home users in a multi-user context. So this is my research question. So I've broken down this to 3 sub-questions. So this is like the big picture. So there are smart home users, and they have their specific set of privacy preferences. They have different capabilities. And this information needs to be captured in a way that decision engine would understand to invoke the adaptations. And also there are user interfaces, and that needs to be captured in a language which the decision engine understands. So this is my first research question. Like I look at ways that to model these preferences, capabilities, and the user interfaces. The second research question is with regard to the decision engine. I'll be looking at algorithms which actually can take this information and invoke adaptations to preserve privacy with regard to the user's privacy preferences. And the third research question is like how I can put all these things together and come up with a middleware where this can be tested out in the with real users. So with regard to the method, so this is similar to the previous slide. So these are the 3 main sub-research questions. So as I mentioned, the first one is about modeling these user interfaces and privacy requirements of smart home users. And for that, I'll be using a case study to go through a few scenarios that I have with regard to my research and demonstrate the capability of the modeling technique to represent the scenario. So that I'll do that through a case study. And the second one is to go through the algorithms to see how it can analyze and invoke adaptations to the interfaces. So I'll be doing that. The method that I'll be doing to assess that research question is through simulations. Then the final question is like to put the results from the first 2 sub-questions and then come up with a middleware which actually can run in a real smart home scenario. And for that, I'll be doing a user study to see how well my middleware framework could actually preserve privacy of the smart home users. I've been working in the first research question with regard to the modeling aspect. So for that, I've used a language called Ray. It's a general purpose policy language, which is used to capture different privacy policies. So I've used that in a smart home scenario where people have different privacy preferences, and that to capture each user's privacy preference. So with regard to user interface modeling, I've used a framework called MASP. So that sort of captures existing user interfaces in a smart home, which actually can be combined with the Ray language to come up with my solution for this problem. So this is like the future work and what I've done so far. So I've sort of almost finished with the first sub-research question, where I come up with a case study to represent the scenarios using the policy language and the MASP framework. And the second one is a simulation. I'll be going through the existing modeling techniques and to run simulations. I'm actually working on that question at the moment. So the final question is actually to go to user studies to test this out in the wild. So yeah, that's a plan for the future. I'm happy to take questions.
Yes. So We'd like to encourage students to answer.
We're all students, correct?
Yes. Well, yes, yes. So,
And the students have run out.
yes, go ahead.
Can you give an example of the logic that was used to write the policy rules?
Right there?
The policy rules, you say here that you use brain.
Exactly. So, yeah, I should have had that. So I represent the information and the user interfaces as the object, where this I present this scenario as a role-based access control system. So the people, I write rules for my personal information or with regard to user interfaces as an object that people try to access. And so I write the rule in a way that I give access to set of people, and like I deny access to set of people. So when it comes to the real-time adaptations, to the decision engine look at the existing rule base and see whether the people have access to this information or whether not. So that whether to mask that user interface or the inputs broadcast stream. So that's how I do it. So yeah. Yes.
So are you also planning to consider privacy of the outsider who comes into the home, who is not aware of sensors being present around him, like if the camera is on and if he changes his clothes in a room?
It's not in my scope. So I look at the smart home users, so people who can actually define rules, so who can define rules to the smart home, so that the smart home would actually preserve. But I mean, in a general point of view, you can actually protect people who are not aware of these sensing, but it's not in the scope of my research. Yes.
So, if I think about my own home, which is completely automated, how do you determine policy based upon different devices? I mean, we're a family. We own the entire home. We own all of the rooms.
Yes.
How would you differentiate, privacy needs between members of the family, and how do you assign devices and sensors in such a way that this could make any kind of sense?
So you wouldn't have to write rules with to exactly how the privacy should be preserved. You'll be writing rules like how you decide to protect your information, and whether you need to be you need to have right to be let alone in different circumstances. The decision engine should be able to assess the available user interfaces and come up with real-time adaptations to preserve that. So the object is to minimize the amount of work that you have to do, so that the system can actually assess the available user interfaces and come up with adaptations. So that's the plan.
Yeah. What do you see as the hardest part of the research that you're doing? What's the most challenging area, and where would you like help?
So I think the one I'm working at the moment it's a bit challenging. I've tried to represent this scenario in a function mathematical formula, so that I can sort of have to generate adaptations, because there are so many ways you can do the adaptations, and there are so many possibilities. So how to prune this tree of possibilities? So that's where I'm sort of stuck at the moment. So yeah, that's where if I need help, that's the place. Yeah, thank you.
Alistair, would you still like to?
Sorry. Actually, the question I had here was better than mine, but never mind. I just want to start off by saying that was a great talk. It was a really good, really clear exposition of what you were doing, and really clear from that how you're sort of breaking up the problem. So one of the questions, it's Stuart, isn't it? So one of the questions I had was very similar to what Stuart was asking. It seems to me from your the very first slide you put up, there's the potential conflict between different constraints. So if I have one set of constraints that says, let's say, my wife is, let's say that I'm a carer for my wife, let's say, and she has a seizure or something, then I expect to be alerted. That's presumably part of the smartphone, smart house environment. but also I want to be going off and meditating and I don't want to be disturbed. So if she has a seizure while I'm meditating, then there's a conflict and constraints. And that sort of conflict will be quite difficult for a non-technical person to think about, right? And the whole point of the smart home is to make these things easy for non-technical people to think about.
Yeah.
So where do you think that managing that sort of constraint should happen? Should it be in your reasoning engine, or should it be in the user interface? Is there something that you would flag up initially as being a problem and say, do you want to sort this out, or do you expect your reasoning system to be able to manage it?
So that's a good question. So one of the things that we at the beginning when you write rules is to give priorities. So whether there are rules that needs to be prioritized or others. So in the example you gave, like if there's a health condition like health emergency, having the peace of mind to meditate is not a priority, but it's just in general understanding. So I think when I actually...
A lot of users will find it difficult to prioritize, and actually, if I'm in there and I think, being alerted when my wife has a seizure is pretty high priority.
Yeah.
My children probably think that arguing over the television is equally high priority.
Yeah.
So there's this question of, I guess, how you're going to communicate to the range of users, which was Stuart's point. How you're going to communicate to the range of users what they think about.
If you have a quick response then, please.
Sure. So one of the ways I can solve that is to, when you write the rules, to go through all the possible conflicts that could arise, and probably prompt the user to make a decision on that, whether how the user would actually solve this problem. So that would be saved in knowledge base and would actually go into the decision engine for further adaptations in the future.